Hey everybody, this is Paul. Welcome to lesson 53 in the Intermediate Algebra series. So in this tutorial I'm going to be solving this absolute value inequality here. And basically, if you remember from lesson 50, I explained that if we have some absolute value of some expression, and if that is greater than some number which we called n, then we have two parts to this solution. Basically, the first one is the expression is going to be less than negative n, and it's also going to have a second part, and the second part is going to be the expression is greater than positive n. So we have an absolute value inequality of this form here. In our case, our expression is 6x minus 3. We're taking the absolute value of that expression, and that's greater than some number n. In our case, n is 27. So we're going to go ahead and just start out with these statements here. And so we're just going to rewrite expression as 6x minus 3, since that's what our expression is. Then the less than sign, negative n is 27, so negative n is negative 27. And in this case, our expression once again was 6x minus 3. That's greater than positive n. Positive n is simply 27. So now we're just going to do some algebra and solve these two inequalities. So we're just going to add 3 to each side of this inequality, and we're going to do the same for this one as well. So 6x minus 3 plus 3, the minus 3 and the plus 3 go away, they go to 0, so we're simply left with 6x on the left hand side here. And this right here is the exact same thing as this, so we're just going to write 6x for this one as well. And so now we have less than. Negative 27 plus 3 is going to give us negative 24. And then on this side we have the greater than sign. 27 plus 3 gives us 30. And so now we just want to get x by itself on the left hand side of both of these. So the way we do that is we simply divide each side by 6. And 6 over 6 gives us 1. 1 times x just gives us x. That's less than, this is a negative 24 divided by 6. Well, a positive 24 divided by 6 gives us 4, so that means a negative 24 divided by 6 gives us negative 4. And then on this side right here, 6x divided by 6, just like on this side over here, gives us an x. That's greater than 30 divided by 6 gives us 5. So this is basically our solution in two parts right here. So we can have x less than negative 4 and x greater than 5. So let me just go ahead and explain this up above. So I'm just going to erase some of this stuff now that we've already worked through this. And I'm going to put these numbers up top so that they're easier to see. And basically what we're going to do here is I'm going to rewrite this in set builder notation. And the way we do that is set builder notation, we simply have these curly braces, and then we define some variable. We're going to call ours x, and then we put this vertical bar. And basically what we put on the other side of the vertical bar is how we're going to define our x. So we're saying that we have some thing, and it's called x, and x can be less than negative 4. So we just simply write x less than negative 4. So this basically means this is what we're going to define, and on the other side of this bar means this is how we define it. So this is our solution. We can have any number less than negative 4. And for this one right here, we just simply write opening curly brace, x, and then we define our x, and we say that our x can be anything greater than 5. So those are our two parts of our solution. And since we want both of these chunks, we simply write a capital U here for union. It means we want this piece and this piece. So let me go ahead and just draw this on a number line now so you can actually see what I'm talking about more clearly. So if we have some number line here, and let's just say that we've got 0 in the middle, we're going to go up to the value 5 over here, and negative 4 looks like it's about there to me. And so this little set right here says that x can be anything less than negative 4. So negative 4 is here, so less than negative 4 is all of this stuff over here, and it just keeps on going to negative infinity. And over here, x can be anything greater than 5, so it can really be anything greater than 5, so it's all this stuff over here up to positive infinity. So our solution doesn't include anything in this range. It's just this part and this part over here. So basically, if we were to choose any value less than -4 or any value greater than +5, and we chose that value, plugged it in for x, then this would produce a true statement. So just for a quick example, we could choose -5. -5 is over here somewhere. And that's part of our set right here. So it falls into this category. So -5 is part of our set, so it should produce a true statement when we plug it into this absolute value inequality. So let's go ahead and do that. So if x equals -5, then we have -5 times 6 would give us -30. And then -30 take away 3 more gives us -33. And then if we have the absolute value of -33, well, the absolute value is just going to make that negative number a positive. So this becomes +33 now. And +33 is greater than 27. So that was just one example of how we can produce a true statement by choosing a number in either this section of the number line or this section here. So basically, any number you pick anywhere in here or anywhere over here is going to make this a true statement when you plug in these numbers for x. Now, on the other hand, if you were to plug in anything in this range for x, you would produce a false statement. So that's the basics of solving an absolute value inequality. I'll go ahead and do one more example on this, and then I'll go ahead and move on to another topic. So anyway, thanks for watching. Stay tuned for the next tutorial on absolute value inequalities. You guys have an excellent day, and if you haven't already, don't forget to subscribe.